Hello, welcome to another round of P5 to V4. And this time we again continue with the coding challenge of the amazing coding train. And this time we want to do number 6, which is mitosis. And mitosis is basically behavior in cellular biology where the cells split and two new cells appear when they split. And yeah, this process continues. We want to build something similar in before, just that we in our example don't have to click. We have a timer with an LFO, and every time a new cycle starts, the cells split and duplicate one of them. So let's have a quick look at what we have here. So we have a cell object with a position vector, which is created at a random position in the beginning. And we have a radius, and we have a color, and there is a function which gets clicked, which gets executed, and it basically tests if we have clicked into the circle or not. And this is in our case not important, but yeah, what happens here is basically it's calculated the distance between the position of this cell and the position from the mouse, which is here passed as x and y, and it returns true or false. Then we have a mitosis function, which when it's called creates a new cell at the same position of that destroyed cell with a scaled down radius of 0.8 and the same color. And then we have a move function, which basically just moves this jittery move of the cell, which is a velocity random 2D vector, and that gets added to the current position. And for the show, we just have an ellipse. Pretty simple. And for the rest of the sketch, we create two cells in the beginning. We have a list of cells, and in the draw function, we move and show all the cells. And when the mouse is pressed, we pass, as I said before, the current position, or in this case, the position of the mouse, into that cell, and two new cells get created with the cells.push. And yeah, the mitosis happens, and the mitosis function for that one, yeah, creates a new cell. So, and then the clicked one basically gets removed from the list of cells, so it doesn't stay. So okay, so let's move to V4 and see how it's done here. So we also have this mouse display. We have this cell record, And when we see here in the constructor, so we have a position, we have a radius, a direction, and a speed. And we set these values on create. So yeah, on the creation of the program or the patch, we basically create one cell with a radius of 0.4 and a certain speed, no direction, and position 0, so in the center, and we basically just create one. That's why repeat one, but if you would like to create more, obviously could. And this gets passed into our spread of cell, which is basically the list equivalent in V4. And what we do then is we have this LFO, which every 5 seconds a new cycle starts. And if the new cycle starts and the counter is smaller than 60, so to limit that just a certain amount of cells can be created to, yeah, don't make your program get slow or something. We just limit that. And if both are true, we basically the new cycle gets passed on in a talk edge, and that one triggers the if. And in that if region, we use that get slice to pick a random element from that cells. So we have this random from 2, which is from 0 to the max to the count of the cells spread. So we have the maximum range we can pick from the spread. And yeah, we pick a random slice and we remove this instance. And if we go inside, we see that basically we have the current cell as an input. No, we have the spread as an input. Yeah, here. So if we go in there, we rename it to spread. We go out, we see it's this input, because that one is the default input from the record. So yeah, we pass in the spread and we remove exactly this instance of the record, and we can use this node for it. And what we then do is we basically pass out the spread where the element got removed, and we use that spread to add 2 more cells. So we have this mitosis logic. So first we remove that instance that got randomly picked, and for that instance we execute the mitosis function. And if we go in here it's a little bit more logic. So what we're doing here is, let me see if I can make this prettier. So we have this mitosis function. Let's see, we run mitosis here. So we, in the mitosis function, we take the current position of that destroyed cell, and we take that radius, and we basically create So yeah, we take the same radius, we negate that radius to define at which position the new cells get created. So we want basically we want to the new cells be created inside that old one, and to have a random position inside that radius, we basically take the radius, negate it, and set this as the random new position that gets added to the position, and that gets added to the initial position of the new cell. And as in the example from the coding train, we also scale down the radius here. So we multiply the current radius, or from the destroyed cell, we multiply it with the 0.78 and set that as a new radius. So the cells get always smaller and smaller. And we set a new speed. For the direction, because when we restart this, we see that the new cells pop in like diagonal directions. So they're always like split in kind of like on the same line, but in different directions. And for that, we pick a random angle. We calculate a random angle by using that random from 2, so from 0 till 2 pi, which is the full circumsphere of the circle. We pick a random angle, and then we use the positive version of it, because it goes from 0 to 1, and we negate that. We negate that and subtract pi, so we get the opposite of it, and we both fill that into the cons, and this cons is basically then a spread of float. And because we repeat this logic 2 times for the 2 cells that get newly created, it for the first repeat picks the first element, so just the positive one, and for the second repeat it picks the negative version, so from the cons from a second input. So this is the way how we can assign basically, yeah, for each iteration a specific value, and we take that, and this outputs a spread of cells because we iterate 2 times, and this spread of cell gets added into the spread that we put in. So here, and in the for each, we pass the spread as an accumulator, so we can basically add to the whole spread the new elements, and then we pass it out again as a spread with the accumulator and out of the if, and then we just execute the update logic, which is in our case, yeah, we every time update runs, we add a random value to the current position, and we also add a little bit of random speed, or we change. Yeah, we basically change the direction of it a little bit and add that to the position. And yeah, let's see. Yeah, I think this is not important right now. So if you would like to change, oh yeah, okay. So yeah, okay, now I get it. Okay, let's undo that. So what this logic basically is doing, because when the new cell gets created, the cell, we want to like burst it out. So like we have this little short movement, and we basically give it a speed of 0.03, and then we subtract from that speed in a 0.02, and this basically makes it from going really fast to going slower towards zero, because the speed gets every time it bursts out, every step it gets smaller until it gets zero. So if the speed is bigger than zero, it still like continues, but if it reaches zero or smaller than zero, we just set the speed to zero and it ends at their end position. This is what happens here exactly. And yeah, this is just so yeah, the burst happens in that direction. So we use the direction variable multiplied with sine and cosine. So it's like on a like it moves like on a circular level shape. And as long this is bigger than zero, we multiply it and add it to the position. But when that turns zero, basically this is inactive and we just have at the random position here. Yeah, that's basically what happens there. And then we store the changes back into the spread of cell. And at the end, we just have a draw with circle and the fill and use the radio and the position, and we output that layer. And we have that inside of for each. So each cell gets rendered and we group it afterwards in a spread of layer, and we group it again. If we like might want to use a mouse or something, we can at the end here, and we create a skier texture. And what we can do then is can have some fun with the visual, because without it, it's basically this. So we have like just some basic cells, but as I always like to point out what advantages you can get when you do it in V4 is obviously the effects, the visual effects that you can add on, for example. And another example is you can export it as an Excel, so you can have like a program that you can run executable. You can run on your machine without needing V4 open if you need for an installation and much more. But yeah, we can use now after the skier texture, because it converts the skier layer into a texture, which we then can manipulate in via stride texture fx. And yeah, we can have obviously a lot of fun with the effects. Where's this highlight boost? We can create even like a yeah, really jittery, fun, almost like exploding effect. It obviously takes a little bit, almost like fireworks, but ooh, yeah. If we boost the saturation more, you get really interesting. I don't know what I did there. And obviously you can also decide which where the effects happen, or we get like interesting scan lines here. Yeah, I mean, there's like limitless opportunity with this, obviously, as usual, with this amazing tool. And yeah, what else? Let's see. I can use the basic texture and place it. That is obviously too big. Yeah, not really. I wonder whether to try. Yeah, we could. Oh, yeah. If you want that cell vibe. Obviously, a little bit more. Just can. Whoop, not that. Take that toggle is off. What? So that you. Now we're getting even interesting effects. Let's wait a little bit and see. Ah, maybe want even like a little bit. A little bit structure. But yeah, I mean, obviously you can go crazy, or just, I mean, yeah, experiment a lot. But yeah, thanks for watching. I hope you learned something new or got inspired. That's why I do it. Let me know if you are liking it or interested in other things that I can do or explain or build. Yeah, thanks for watching. Have a great day. Bye.